Okay, this talk is called Designing Go Services for Continuous Deployment. My name's Am, I work at Vend, and wow, following up on that talk. So, I'm going to begin with a premise. Speaker notes. Sorry, let me just adjust this. We're just going to have to go with... Sorry, just going to have to go with the title bar. I'm happy with it. Thanks. Okay. Sorry. All good. So, continuous deployment. Nearly there, nearly there. There's my speaker notes. They're coming. Come this way. Damn. Okay. So, sounds good, right? Maybe a stretch. Let's test the premise. I'm going to touch on a lot of topics, and it might feel a bit rushed, but don't worry. I'm going to provide samples and a code base with a memorable name so you can look it up after the show. But first, what is continuous deployment? So it might mean different things to different people in the audience, but for me and for the purpose of this talk, it's a release strategy. Any mainline change, so a change to your master branch in your code base that passes testing, is automatically released into production. Continuous deployment automatically put your working software in front of users. That means any push or merge to master. Wonderful. So if you just think about doing that with the code base you work on, and I don't know what you feel, hopefully calm and peaceful. Oh, internet. Oh, I lost my GIFs. But there's a yeah, sure, GIF coming. Well, there should be one, but never mind. There's only a couple of GIFs in this, so I can speak to them. So, okay, it does sound a bit super risky, and maybe it feels uncomfortable to think about. But there's some work to be done, and some culture implications, and some other caveats that I'm not really going to speak to. I want to talk about Go and about code. So let's explore. So let's make up a story, and this story is about a gopher, and it's called Toasties Galore. There's our heroine. Her name's Geeta. She's Geeta the gopher. She's an innovator with a passion for technology and for melted cheese. This is her food stall. It's called Toasties Galore. And she's starting a business, and she's going to beat the competition with advanced cheese technology. Yeah, another drawing. State-of-the-art technology. Geeta builds her own machinery. It's software-driven, and you and I are going to build the software to drive it. So Geeta's a hardware freak. On the left, we've got something called Chili Bin. Chili Bin is a New Zealand word. I believe you call it an esky here in Australia. And it's where we keep the ingredients. Then we've got something called Jaffla. Shout out to a famous Aussie invention, the Jaffa line. And this is a state-of-the-art grilling machine. Uses lasers to melt the cheese just right in no time at all. And it's got this mechanical arm. And that fetches the ingredients for Chili Bin. So that is representing the interaction between two services. So we're going to have a quick look at the Toasties Galore codebase. This is a monorepo containing two services, Jaffla and Chili Bin, which interact with one another. It's got tests, it's got Docker things. The content doesn't necessarily strictly apply to Docker or the tooling I'm using, but there it is. It's got scripts, it's got tooling, and a CI/CD pipeline. And now I've got a Wi-Fi thing coming up. So, let me just get out of the way. For the presentation, let's look at software supporting this imaginary food stall. So a monorepo, first of all, is just a... It's all right. I had it open. Okay, it just got pulled off during the confusion. So I'm just showing you this as a rough guide. We've got a couple of services defined there. We've got some scripts. You can go in and play with it, fork it, and we can see here it's got a Travis pipeline and Docker things, Docker Compose. So next up, the Toasties Galore software architecture is back here. Cool, so it's very simple, as you can see. When Gita, using a very minimal UI, sends a request to create a toasty, there's just a sequence of events that happens. We get an HTTP request, goes to Jafla, which initially just sends a call to Chilibin to get some ingredients. Chilibin's using a Postgres database, and then out the back we get a toasty. So the main thing to note here is contracts between Jafla and Chilibin, and also Chilibin and Postgres. This is my slightly messy attempt at diagramming the pipeline. So we've got a CI/CD pipeline here. For any given change that makes its way to GitHub, we've got a webhook that's going to inform Travis. So Travis is just a CI/CD tool that comes as a service, and for me, for this public repo, it's free. So we're going to verify that the code is good. We're going to do some tests, maybe some linting, some build, and then we're going to publish to Docker Hub. Now, if it's a change to the master branch, we're going to go ahead and deploy. We're going to go, having done all these verification steps and published to Docker Hub, we're going to try and push it to production. So the top box, as I said, represents any change, maybe a feature branch. Bottom is only executed when you're on the master branch. So quickly show you what the pipeline looks like in travis.yaml. So I've highlighted in bold, I don't know how well you can see that, a few important lines. So first of all, we're going to run some tests. You might think of that as continuous integration. Then we're going to prepare and then run some integration tests. Now this is something that I think is particularly significant for CD. Then we're going to publish, and then we've got this second section down the bottom, so the first section being the script section, then the deploy happens conditionally branches master. It's short. We can have a look at the pipeline, how it's been running on different branches. This is what you kind of see. You can drill into them and see how long it takes and why it went wrong. Okay? So, next up, auto-deploy is scary. This might be what you're thinking. Maybe you liked it until you saw the deploy section, which would be fair enough. We're going to need to do some things for this to work out for us. So what's the baseline? What's the bare minimum we can do to make this work? So let's consider some important things. For me, the first three things I'm thinking of are observability, seamless deploys, and integration tests. What's the bare minimum? Observability, what's happening in production? I need to know. This is something that may be provided for the most part by your platform, but within your code, there's going to be some things you might want to measure. Seamless deploys. If I'm no longer the gatekeeper of deliberately clicking a deploy button, I want to know that when the deploy does happen, it's not going to interrupt our service. Thirdly, testing. It does change the way we think about testing, I believe, and I think from a survey I did, most people seem to agree that integration tests are the place where we feel like we need to do that bit extra work. So let's look inside this component, Jafla. That's one of Gita's drawings, so let's go past that and have a look at the main function. So in the main function, first thing to note is, again, it's quite short. It's doing a few things. First of all, it's doing some config things. At the top, it's reading some environment variables with some defaults. It's setting up some wiring of some handlers to serve up an HTTP server, and then it's starting some things. First thing it's going to start is something called a graceful shutdown for timeless deploys, and then it's going to start our server. I've highlighted in bold again the mechanical arm. This is representing, oh, that's the bit that's scary that we want to test more thoroughly. Second one, middleware for observability. This is one of some places that you might want to instrument your app, and then I'll show you this graceful shutdown. So first of all, instrumentation. I believe there's going to be a talk later where we're going to be hearing a lot more about middleware. So middleware, I won't go into it too deeply, but basically there's a little bit of work. So this is a wrapper around an HTTP handler that's going to do a little bit of something before and after, could be just after, but in this case, we're just going to try and record, we're going to record what's happened in this request. So in order to do that, we're just going to set up something to capture the response code and get the timing, and then we're going to label it. So we might be using one of several services like Honeycomb, Prometheus, StatsD, Datadog, and so I've tried to sort of abstract away from the specifics and just say we're likely to want to put some labels there so that we can graph and then subsequently build some alerting around that. And why not throw in the version so that we can compare version by version if there's any patterns, anything that went wrong when we deployed. Okay, seamless deploys, the rolling update. All I want to tell you about here is that this is one thing that's built into Go, and this is how it would look. How it would look inside of a Go service. So basically, what this is doing is reacting to a platform that might be Kubernetes, might be ECS or something, where it's going to inform your app that it's time to go by sending an interruption. So it might be a kill or Control-C, and the way we handle that in Go is to subscribe to this channel, and we're subscribing to OS interrupt. And as soon as we receive that, we're going to be able to do something to stop the app just dying suddenly. And what we want to do is for existing connections, existing requests to keep on serving, and that's represented down below. Okay, that's just a built-in. There's other, if you're not using HTTP, then there's other things you can do, but this is just one example. Okay, so that's 2 out of 3. Next, the big one. This is integration testing. So this is like, if you think of the testing pyramid, this is at the top, where in the past I've treated this as we don't need a lot of tests here, we're just trying to test these interactions. Within each service, we might put much more thorough testing, but here, this is just doing, it's got 4 stages. Reset the environment, so we've got predictable state. Check that state. We've got a method under test, check the result, and then check the resulting state. So things to note here, we're invoking the outer service, asserting the response, and then asserting the state of the inner service. So we're testing that relationship. We're not assuming state with the reset at the start. And then another thing to note is these tests are independent of the environment. So these addresses another environment variable. You could run this against prod or against a test environment or against your local. Okay, next. After doing this work, I'm feeling a bit more comfortable, and I'd just like to show how Toasters Galore in this fictional world is now a highly successful operation. Gophers love the recipes. Jaffa is busy 24/7, and I don't know if you can see how much happier Geeta looks, but she's very happy. But then, conflict. Some Gophers aren't happy. We're super busy. Some orders are going to the wrong Gophers. So Gwenda got a pineapple instead of Vegemite. Gary received cheese instead of soy cheese. Not good. So how are we going to deal with this? We've got design problems, and we need to make decisions. Geeta's first thing is she wants to track who ordered what, and secondly, we've seen when we do this, we're not comfortable with the way the API is designed. So this is a before and after of a change we want to make, and we want to change that request, currently a GET, which doesn't feel good because it's updating the ingredients that are stored in the chili bin. We want to change it to a POST. And we want to insert rows into a new database table. Cool. Oh no. Oh, I got a GIF. Good. So the API signature needs to change. DB structure changes, and Morty is scared. So at this point, we're a bit worried. Geeta says it's all good. Let's dance. Oh, I don't have that GIF. So I chose the foxtrot. I missed a trick here because I just wanted the name of a dance that's 3 steps. I could have called it Waltzing Matilda, but never mind. Too late now. So let's dance. 3-step dance. Step 1, add a new implementation. Step 2, migrate comfortably. Step 3, delete the old implementation. Okay, so what we can do, and with CD, it's not that you can't do it without CD, but with CD, it's easier. You'll consider this kind of thing more often. So we're just going to line up 3 pull requests. Step 1, implement PIC-v2. Step 2, invoke the new endpoint from Jaffla. And step 3, always invoke PIC-v2 and do the tidy up. So each stage may take a while or not. Like step 2 in particular, you might do feature flags, gradually gain confidence. The main thing is, it could be quick, but you give yourself the chance to reassess after each step. So step 1, we'll have a quick look at the code. Serve the new approach under a different URL. Sorry, is the sound all right when I'm not by the mic? I hope so. Serve the new approach under a different URL, v2 pic. Now there's 2 versions of pic side by side. v2 can be tested manually, but it isn't invoked by any other service yet. No changes to Jaffla, just Chilibin. So I've got that open, thankfully, over here. And we'll notice there's a few things here. So first of all, in our handler, we're going to rename it, and we're going to do a bit of refactoring. We're going to extract a method where previously we're doing this update statement, and we're going to add a second implementation. And then there's the refactored extracted method. And then we're going to add a second route. Oh, scary. We're going to do some DB migrations. And we're going to add another test, just so that something's verifying that our new feature is okay. Okay, so let's go back. So step 2, invoking the new implementation. This is being done conditionally at this point. In this case, we're using a feature flag. So we're going to say if in the initial deployment, initial release, we're going to say if customer is Geeta in a carefully selected condition, we're going to allow this change to be executed. So step 2 might look like this. So we'll make a little change to a test. Then this is where we change Jaffla, the calling service. We've got adding a new method to our client, and then we've got this features could be implemented as a separate service. That's what we do at Vend, but it could be something super simple like this. And then based on that, we'll decide whether or not to use the new feature. Cool. So next. So yeah, alternatives. There's things like canary deploys, shadowing, blue-green deploys. I feel like I'm pushed for time. I'm not going to try and explain those. And then the third one, it's really important, but it's kind of the easy part, but a part that can easily be forgotten. And why not line it up in advance? Otherwise, you might forget, and do it soon. So that's just deletion and removing of that feature flag check. So the conclusions I'm drawing from this are, when deployment is a non-event, you can make releases safer, and your code will end up cleaner as a result. When you have more viable options within easy reach, you're empowered to make better decisions. Cool, so that's the end of the story part. At this point, I'd just like to share some general tips and tricks or caveats and things that went less well as I've tried these techniques. So first of all, on configuration. Why not, once deployment is easy, why not just deprecate your extensive config files? In some cases, we have put a lot of stuff into our config with the sense that if there's an emergency, it's late at night, we can just edit the config and redeploy. Also, knobs and twiddles, it's nice to think we can tweak things. But with CD, we can simplify. We can use M variables, like you've seen previously, as recommended by 12-factor apps. We can just use a constant. We don't need to wire up config if redeployment of our code is as easy as reconfiguring our service. On monorepos, so this is quite a challenging area, but also quite interesting. So I've worked with monorepos in the past. At Vend, we don't, but it has some interesting benefits and challenges. So it's easier to maintain and iterate on your CI/CD pipeline in one place, rather than having several repos and having to change each one individually. In-house dependencies are all localized, so that also makes change easier. Testing component combinations is also easier, but it presents some challenges when it comes to build. So identifying what to build when a commit comes through, what to test, what to deploy on that commit. Speed becomes a challenge because you're trying to build all the things at once, and third-party dependencies. So I spent some time fighting with Go modules and Dockerizing and trying to do Go modules or vendoring at the top level, and it may be seen as something that's a time sink, so your mileage may vary, but there's an approach in Tosis Galore Codebase on GitHub which you can have a play with. So the main question I want to focus on with monorepos is, do we really need to redeploy everything on every change? Sounds not ideal. So it depends on the language and the tooling available, but in Go we have something. This is our publish.sh script. We also have a deploy.sh, but it's conditionally publishing based on the commit hash. So we're tagging our Docker repo or our Docker image with a commit hash, and then if the commit hash already exists in Docker Hub, we don't need to do anything. If it doesn't exist, we're going to go and build and push it. So let's have a quick look at what Go-specific tooling we have here to help us with that. So we've got go list minus steps is the crux of it. So you can say go list minus steps for my package, and it will, and with a bit of filter use of sed, we can find out what our imports are. There may well be a more formal way to do this, but this is what I've used. And then we pass that into Git, and we say, Git, what's the last commit that affected these directories or files? And so we go back to here, and then based on that, we're going to call that and say this is the last commit. So deploy only affected services. We can use that same little tidbit to decide which integration tests to run before or after deploy. I find it quite useful. But yeah, your mileage might vary. It does feel a little bit like it's risky, or it's quite hard to be sure that we've captured enough and not too much. Quick note on migrations. I'm not sure how I'm doing for time. I think 3 minutes. 3 minutes. Okay, cool. Thanks. Okay, DB migrations. I don't want to talk about it. It's hard. DB migrations will always be challenging. There's some concerns in particular that in different places I work, people are a bit concerned about, hey, this might take too long, or it might delay the release if we run this in a CD pipeline. So there's some mitigations for that. You can use transactions and then test it in advance. So in Postgres in particular, you have transactional DDL. You can go start transaction, begin transaction, and then run your changes. If there's a unique index you're trying to add, it will give you a heads up if in production there's something that's going to be challenging. There's also, you can run them in advance, either by running your migrations not in your app, but in a separate task or separate job, or you can run them manually in advance with, if not exists, in your migration script. But it's tricksy. So also split them up. If there's something that's cheap, like creating a table that you really want to rely on for your release, then do that in one, and the tricky stuff can be isolated and managed and contained. Okay, so I just want to quickly show you the migrations thing. One thing there's a few out there. This is using something called Go Migrate, and this is something in Chilibin we're running at startup, and we've got some files with our migrations that we saw in one of those PRs, and you can actually just bundle it with your Docker container. So there's different approaches to getting these files delivered with your app, but we've just bundled it in the container. Now, at Vend, we have some really cool stuff. I'm quite new to Vend, so I can't claim responsibility for this, but we've got a Slack bot and some other non-Slack bot entry points to do canary deploys, rollbacks, manage feature flags, and find out status of services. So canary deploys is just when you have an additional new version of your app, in our case, an ECS task, which runs alongside the rest and receives a proportion of traffic. Yeah, I've mentioned Travis. There's so many out there. GitHub Actions is the new kid on the block. Just try one, I'd say. So, finish up. Conclusions. How will it change my code? So more than anything else, I believe CD affects how you change your code. CD forces you to deal with important things up front. Most of these have their own payoff, so it's not going to hurt you long term to invest in these areas. CD encourages good practices, enables safe and easy changes. And I believe, from my experiences, you'll end up with fewer contraptions in your code, fewer cobwebby corners, and more options. So more better options based on change being simpler to execute. I would say that if you've got a long-established system where you haven't been using this approach, it is a lot of work to get there. So either start early or add incrementally. Continuousdelivery.com is one of many websites you can go to find out what the business value is and what research has been done on this software engineering approach. So I would just like to say, have a play with Toasties Galore and see what you find out. It's on GitHub. Hopefully the name is memorable, so you'll be able to remember it. And fork it and connect it up to Travis. Do what you like. Thank you very much.
Thank you.